I just named that example B, but it's actually example C. So welcome back, Algebra. We're off to a good start. Cool. So today we're going to jump in. We have one more difference of squares that we want to check. Now, as we go through them, they can be kind of ugly. Like it's going to happen. Give me 2 seconds. I'm going to get us a nicer one. And I just need to be able to see it in front of me. Let's say, quit it. Whoever did it, quit it. So let's say we have 4x squared minus, I don't know, let's call it 36. We want to factor. Do you guys want like 60 seconds to try it or just want to jump in cold or randomly calling people? Jump in cold, I like it. Ice bath it up. All right, well here I am. I have no idea what to do. Number 25, I feel like they're gone. Is that true? Yeah. Golly. Number 3, how do I start every factoring problem ever? GCF. I'm going to do something to help us really quickly today because we're likely going to turn our pages. Factor out our 4. Here it is. This is equal to 4 times, we have an x squared minus what? 9. Now, we've done one little step of factorization. Somebody in here might look at it and go, well, I wouldn't have done it that way. Good. That's totally fine. There's another way to do this, but it's pretty unique. Question? I factored a 4 out of both of them, right? So when we factor out, maybe it's easier to think about dividing, like, because that's what happens. If I took this term and divided it by 4 and moved it out front, because that's what we're doing, it'd just be left with an x squared. Do you agree? What if I did the same thing here? Yep, so whether you think about it as dividing or multiplying, like they're the same thing. If you ever are doubting yourself, just real quick, try to FOIL it out. Don't write it down again, but verify you get the same thing. Okay. Are we done? No, we've done the first step. There's no more GCF. Cool, I'm good with it. Next step then. Middle board. Is it a binomial? No. You say no. Now I agree. Kind of. There's more than a binomial up here. This one can't go any further, right? So let's focus, just for now, let's start focusing on this one. Forget about the 4, except bring it along with us if we go to our next line. Like we don't leave it behind, but we're just ignoring it for now. Is what's underlined in green a binomial? Yes. Is it a difference between them? Yes. Do you know the square root of x squared? Yes. What is it? X. Do you know the square root of 9? 3. It's 3. So it means that on our next line, I can already tell this binomial right here is the difference of 2 squares. Our 4 does not get left behind. I'm going to rewrite this one. I'll do it in green since I underlined it. You guys told me the square roots were x and 3, right? What goes in between these on the first one? Does it really matter which answer you gave me just now? Nope. I think I usually do minus first. Don't know why. And the next one is x plus. Every time it'll work like this. At this point, we always keep looking because we never want to stop if we're not completely prime. Are there any more GCFs in this piece or this piece? Nope. Can you factor anything out of here or do a difference of squares or anything else? Is there anything left for us to do? So right now we have the product of its prime factors. Now, this answer is good. This is the answer that I would prefer. Did anybody else see this a different way? Lily, did you give me a nod? Yes? No. Okay. That's all right. Is it possible that somebody gets goofed up and for whatever reason they try not to check the GCF? Like, it happens, right? I just want to look at, you don't have to do this if you don't want to write it down, because I will always do GCF first. But let's pretend that for whatever reason we just completely blanked and I don't think about GCF. Do I have a binomial? Is it a difference? Do you know the square root of 4x squared? It's 2x. Do you know the square root of 36? 6. So do I have a difference of squares here already? If we approach it this way, I think that I'm going to get the square root of this one is 2x minus the square root of this one is 6. And what is my other factor? 2x plus 6. Did we just get a different answer? Is it really different? No. When we look at it, could I factor a 2 out of this one? And I'll just do that. If I factored a 2 out of the first one, it leaves behind an x minus 3, right? And this is going to look silly when we do it. It's going to look really weird for a second. What could you factor out of this one if we now all of a sudden we remembered our GCF? And what would it leave behind? Does multiplication commute? Follow up, what does that mean? So I like the yes part. What's commute mean? If I commute to work, do I work from home? I travel to get there, right? So it doesn't matter which one of these multiplications I do first. 2 times 3 is the same as 3 times 2. If I put just the 2's together in front, I would call it a 4, and notice what happens. Is either of these forms better than the other, whether it's here or here? Not really. They're going to give me the same information. If we commit to just always doing GCF first, we'll all get the same, most simplified version every time. Cool. Are we ready to bump it up past binomials? Everybody feel like you can factor a difference of 2 squares? Okay, prove it. We're going to go like 60 seconds. Last one, because D does fit in this little arrangement. Last one that we're going to do here. Ooh. I'm going to give you guys a curveball. I want to see what you come up with each other, okay? I want x to the 4th minus 16. Now, I know it's not a quadratic. That's okay. I'm going to pause it. I'm going to give you guys like 60 to 90 seconds. Talk it out. Run through the list all the same. Let's see what we come up with. This problem looks a lot harder. It is a little bit harder, I think. Is there a GCF? No. Now, thank you for saying no because it's 1. Never asking about 1. We don't care about 1. 1 doesn't do anything. So we'll just kick down the list. Is it a difference? I guess rather, is it a binomial? Okay, is it a difference between them? Do you know the square root of each of them? Yes. That's where maybe. Okay, for a difference of squares, we have a squared minus b squared. And I don't know why I have parentheses. This equals a minus b times a plus b every time. Okay, when we're looking at this, you guys claimed yes. Help me out. What's the square root of x to the 4th? Why? Convince me of that. That's an interesting answer for it. Not the one I'm after, but I appreciate it. I heard a bunch of different ways. I heard x squared times x squared is x to the 4th. That's awesome. Michael told me that the exponents add when you multiply like terms like that. That's the same answer, but a little bit more mathy. Love it. Okay, that square root is x squared. What's the square root of that one? 4. So do we know the square root of both and it's a difference? Boom. X squared minus 4. And the other one? Now, I want to be really clear. When I say the other one, I mean, and I'll use this more specifically, the other factor. These are my 2 factors right now. We always need to keep checking until nothing else breaks down any further. So looking at this one, we're just restart at the beginning. Is there a GCF between these 2 right here? No. Is it a binomial? Is it a difference? And do you know the square root of each of them? So help me factor it. What's the square root of this? So the first factor is x minus 2. What's the next factor? X plus 2. Now, I want to be really, really clear, and I wish I changed colors. This one right here just factored down to these 2. Okay, now we'll move on to the second piece. And we won't leave it behind because it's our friend. X squared plus 4, is it a binomial? It's not a binomial? So the question that I think everybody was answering, is it a difference? Do we have a way to factor a sum of 2 squares? We just don't have it. Does this factor any further then? Nope, but can we just leave it behind because it doesn't? Heck no, it comes along. X squared plus 4. How many factors do I have written on the board? 3. And we're going to make sure this language clicks with everybody. This is a factor. This is another factor. And this is my third factor. Cool. 3 factors out of this. Doable. Kind of. The x to the 4th makes it a little harder. Sonny.
Wait, why don't you factor out the 4? Is it because it's plus 4?
Are you talking from here?
No, from x squared plus 4.
Does this have a 4 in it?
Yeah, yes.
Do I have 4x to the 4x squared?
No.
So if it doesn't have a 4, I can't factor it out because it has to be common to both terms.
Wait.
Like, check this out, Sonny. Do me a favor.
Okay.
Factor a 7 out of this.
Yeah.
Okay.
No. What I'm saying is like, you know, there's three factors.
3 factors, good.
You can't factor out 2 from that one, or?
Do both of the terms right here have a 2?
No, I'm talking about the x squared plus 4. You can't
Okay.
factor 2 from that one, or?
No, because I see what you're saying.
Yeah.
Because we don't factor out the square. We only factor out common factors, which is just multiplication. This, do you agree, is really x times x plus 4?
Mhm.
What do they have in common?
Nothing.
Good.
Okay.
Like, it's, I don't know where the hiccup is. We'll keep working. We'll find it. And I'll come chat with you, okay? All right. Let's bump it up. What's cooler than binomials? Indeed. Okay, I made the claim. That was really enthusiastic, and I love it. Cool. All right, example. Trinomials. Okay, as we're looking at these trinomials, realistically, I don't necessarily always follow this exact order, but it's nice. I made the claim that we have seen perfect square trinomials in here. Did anybody in here ever factor with, like, I probably asked this the other day and I just don't remember, with factoring cubes? Little cubes that, I'm going to talk about it for a second. You probably, with Miss Jarvis would be my guess, you probably had red for positive and blue for negative. And then there was a big square like this that was dimensions x by x. And what would its area be? This is my x times x is x squared, right? So there were big squares that looked like x squared. There were smaller squares, or rectangles, I'm sorry, that you were told had a dimension of 1 by x, and their area would be x. And then you had smaller squares still that was 1 by 1, whose area was 1. Does this look familiar at all to anybody? Okay, if you are a very visual learner, in Algebra 1, when you learn factoring the first time, this is pretty reasonable. I'm going to use it one time and only for what we're the very first step here. So I'm going to shorthand I'll write it out. You guys should shorthand. What do you think is my shorthand for perfect square trinomial? PST, 100%. But let's check out a perfect square. Now, we've done these already without being aware of it, and let's see where that might have showed up. I want us to consider the following. So on A, we're trying to factor x squared plus 4x plus 2. Now, nothing changes other than the fact that we know we're in trinomial, but we're going to just drill this into your brains so that it never leaves. First thing I always check, every time. Greatest common factor. I have a 1x squared, a 4x, and a 2. Is there anything other than 1 that goes into all three of them? No. Okay. Is it a binomial? No. How do you know that? There's 3 separate terms, right? Now, even though this is 4 and an x together, if they're tied with multiplication, it's its own term. If they're separated by addition or subtraction, you count them as separate pieces. There are 3 pieces here. Okay. For this one, if you've ever seen it, I just want to build this up over here, and you'll see very clearly why we call these perfect squares. If I draw an x squared, and this is entirely up to you if you want to write it, but I think everybody has either seen it, or if you haven't, we'll make sense of it. Everybody agree that if this is x by x, this is an x squared? Okay. Now, if I do plus 4x, and I said that these things right here have a dimension of x, because it's 1 by x. Do I have, how many x's here? There's an x and an x. You agree it's 2x? Okay. If I, for whatever reason, add 2 more here, and we'll check this out here in just a second, and I'm going to make one little change. There's another 2 x's, right? I can already tell that I have a mistake. Do you want to see it on the picture, or do you just want me to change it here? I'm going to change that 2 to a 4. And look at this. It was actually a 4 all along. I'm just taking a very stylistic approach. I'll make it a nice 4. I'm going to change this to a 4. Okay. Now, if we look at this picture, and I'll change that so it stands out really clearly. If I wanted to put little smaller squares here, how many do I get out of it? Do I have a square on the board right now? Yeah. Okay, it's perfect. Like, we'll pretend it's perfect because I'm perfect all the time with my drawings. It's a perfect square. Help me out with this side length. So you say 5. Why 5? X. So remember, this is 1 and 1 and x by x. So here's our lengths. So this is x plus 1, which is what? X plus 2. Did I lose you? This is 1 by x, whose area is x. This is All right, we're going to back up. Maybe the area model was a terrible choice, but we're just going to push through it. If I just say this is length x, everybody okay with that? And the big square is then x squared. Okay, this rectangle is still the same width, so it's still x, right? Cool there? I'm just going to tell you, just for now, because it's nice, we're going to use 1 as the length or the height of this one. So it's 1 by x is what this is. When I look at this side, then in the way that my rectangles are arranged, I have an x plus a 1 plus a 1. I think it's x plus 2. What's this side? Do you agree that this square here is just x plus 2 times x plus 2, or x plus 2 squared? Like, I can see it physically on the board. Now, if you hate this, I'm totally good with that, because not going to lie, I kind of hate this as well, because I think we can do it nicer without this. But if you're a very visual learner and you've seen this, maybe it helps. If it didn't help just now, just ignore it. Pretend like we didn't do it. Here's how I actually approach these. When I look at this, this is the nice geometric picture. I can see it's a square. There's a very strange process for these ones to make it work nicely. Check it out. We're going to check this. I want to know the square root of each of these. Square root of these. And I'm just going to say, what are these guys? What's the square root of x squared? The square root of 4. 2. Okay, so if we can take both square roots, that's a good sign. Right off the bat. This next one, I'm going to change color, and this is a weird step to try to jot down and write down nicely. We'll go brownish. Looking at this one, is this thing the product, or twice the product of the roots? Now, when I say the roots, I'm referring to the two that we just did. If you take x times 2, you get 2x. If you double it, what do you get? Is this indeed twice the product of the roots? If and only if this happens, and this is the way that I check it instead of drawing, we have a perfect square. Where we go through this last little piece, we are going to write this out as its perfect square factorization. We'll simply write the square root of the first one, x. We'll write the square root of the last one, 2. And then our last little comment that we need to make, what is the sign on the middle term of our trinomial? On middle term, is it plus 4x or minus 4x? Okay, the term on the middle term is plus. I'm going to write a plus right here. And squared. This is a super convenient shortcut. You take the square root of the first, the square root of the last, verify that multiplied and doubled is here, and we have our nice factorization. Where have we seen this? X plus 2 squared, what does that kind of look like? Kind of looks like our vertex form of quadratics. And in fact, this is one of the ways that we're going to be able to get there. There's a little bit more involved. This is the weirdest one. We're going to do one more like this, and the good news is that if you do this one, you go, nope, I hate it. You can legitimately never check for perfect squares and still factor well. It's convenient because it saves time. Let's try another one. Should we do one more together before I make it do one on your own? All right. So on B, let's see here. I want us to factor. We'll make it another nice one. 2x squared plus 12x plus 18. All right. A very similar problem. We're going to do it without a picture this time. First thing, always, Gojo, what do I do? Very first step, always, with factoring. What's the very first thing you want to do? GCF. Awesome. Is there a GCF on this? Anything that goes into all three terms. 2. Everybody cool with that? I'm going to factor out a 2, and I need you to tell me what's left behind then. So here we go. We won't lose our 2 in the end. 2, what gets left inside my parentheses? Somebody second this. Okay, I'm cool with it. Now, I have a 2 as one of my factors. It's just a number, that's fine. It's not going to mean anything in the very end of our problem. It's actually not going to mean anything because we're just factoring right now. What the inside piece right here, we just restart the process. Is there another GCF? Is it a binomial? Is it a trinomial? So now we're going to kick in. The first thing that I always check with trinomials is my perfect square. So let's look into this. Can you guys take this square root right here? X. Can you take this square root? 3. If you multiply these and double them, do you get 6x? Okay, that is exactly what we need. We can now write our factorization. We have a 2, comes along for the ride. And you guys told me it was x and a 3. What about this middle sign? Why? So not necessarily because it's all positive, but because this is positive. If this middle term is positive, we just rewrite it right here. We are done. It looks more like our vertex form now because this one had an a value other than 1. This is a convenient shortcut to have, but again, I want to stress you can do it without, you can factor everything without this. I would recommend using it though. Okay, I want one more, like this. And then we're going to move on to our last couple options here. So one that I want you guys to try. You want an ugly one? Do you really? Okay, interesting. So let's see here. Okay, let's go. Oh, awesome. 3x, nope. We're just going to make it x squared. I'm not going to make it super ugly. Minus 18x plus 81. I want you guys to factor this one. Sonny. Yes. Square root here. Square root here. And I'm going to square these, and this one's going to look silly just because of how much spacing there is. What's the term in the middle? Negative here, negative here. We're done. We're done. Yep, it's x minus 9 times x minus 9 if you want to write it as both, but we're done. Why no first, just out of curiosity? Okay, you're good. Sweet. All right. I'm going to let you guys choose here real quick. Nope, I lied. I don't know if I'm going to give you homework or not, though. Tomorrow might just be a ton of work in class. Cool. All right. We have knocked out GCF. We have done some binomials. We have done perfect squares. We are going to actually go with grouping first. We're going to look at this one. Okay. And then we'll see why I'm looking at that one first. So here we go. Example, grouping. Now, I'm not going to write this down because it sounds so goofy to say it, but grouping works in a very fundamental way. We take a trinomial, I'm going to just refer to it as a threenomial out of convenience. We take a threenomial and we rewrite it as a fournomial. That's like the magic that happens here. Instead of writing with 3 terms, we're going to write it with 4, but we have to do so in a very clever way. So, in general, we're going to annotate the heck out of this one real quick, and let's just dive in. X squared plus 6x plus 5. Now, we're going to draw on some other knowledge here from a second. I'm going to make a couple little notes over here, or right underneath. What's A on this problem, based on the way that we write our quadratics? A is 1, because it's 1x squared. What is B? 6, because it's 6x. And what is C? 5. Everybody okay with that? So, you guys have likely seen variations of this, and you've probably not seen it exactly the way that I'm about to write it. Have you guys ever done, like, we'll just look. Never mind. I don't know how to ask this question because there's going to be like 10 different answers. Step 1, when we do this, we're going to group this. Step for grouping. Step 1. We are going to multiply. I don't know why I did it like that. Step 1, ugly. Multiply A times C. Now, I'm going to show it here how I do it, and I'm just going to recopy this. I just want to make sure we had A, B, and C. If I have this here, I'm going to first multiply A and C. And when I draw it, I draw them straight down like this because I'm connecting it to the 1 that's here. I just don't write it. And the C. What's 1 times 5? Everybody okay with that? A and C every time. Do you guys ever do this with the lines here? Okay. Step 2. Here's the hardest part of factoring. We need to find two factors of whatever this was. Find two factors of AC, A times C, that add up to B. Now, we don't normally have to write A, B, and C. This part is the hardest part because if your mental math isn't great, big numbers make a lot of stuff. My suggestion, if you struggle with mental math, we're going to write them all out and we're just going to look at them. Now, if we do it in a somewhat orderly fashion, and this one's weird because there's only one pair, so disregard that comment for now. I'll give you two numbers that multiply to be 5. That's literally it, right? 1 times 5. I'm going to stick those underneath here, and we're going to see the magic happen. I'm going to switch color for this one. Do we all agree that 1 times 5 are the only factors? If you were to add these, what would you get?
6.
Which is exactly this, right? That's the goal. We, on step 3, and I'm not going to say write the quadnomial. I'm just simply going to say replace bx, whatever that was. In our case, it was 6x, with the two new values. And I'm going to say the new values. I will regularly refer to them as my magic numbers, but they're not really magic. This is where we replace it with the new values to get a four-nomial. Okay, it feels like we're undoing stuff, but I promise the end is in sight. Does this feel familiar? Okay, so if it does, awesome. If it doesn't, awesome. I'm going to rewrite this, but instead of 3 terms, I'm going to use these magic numbers to replace this 6x. So I'm going to write x squared plus, I'm going to leave an awkward gap because I'll fill them in, plus 5. Instead of a 6x, these numbers can be used to rewrite it. Do you agree that if I do 1x plus 5x, whatever I have in green here is just a different way to write 6x? Okay. Kennedy, make sure, like, if you're tired, I get it. This is the most important part of today's lesson, like, legitimately, because everything could be grouped. I have simply taken this 6x and replaced it here. Now, couple things, really common places to make mistakes. If I had written it 5 times 1, would it still work? The order doesn't matter. It doesn't matter at all. This is going to be nicer because I can see what's coming, but it doesn't matter the order as long as you find these magic numbers. When we look at this, we are going to add some grouping, hence the name grouping. So step 4, and we're nearly done. We are going to make or add parentheses. Can I just use parentheses instead of writing the word? Okay. Add parentheses around groups of 2. And realistically, we can say groups of even number. But in our case, especially with trinomials, it's going to be 2. Now, where we add our parentheses really matters. When I do this, I'm going to add them right here. Same step 4. I'm going to add a parenthesis around my first 2 terms here. Have I really changed anything? Like, there's nothing different about my problem except it has parentheses. There's nothing to distribute. Nothing has changed. The next set goes here. I want to stress the importance of this. Keep a sign, a plus sign typically, right here. Never put it inside, because if I do this, now have I changed it?
Yeah.
Very much so, because we would have to FOIL this out and we would get 5x cubed, something completely different. You need to have a sign right there. All right, last couple steps. I'm going to call this step 5 and 6. We want to factor GCF from each group. GCF from each group. Now, this is the only time that I can think of where 1 is ever a good thing to factor out if we have to. This one doesn't, but let's look at this. For this one, what goes into both of these? So x, and it would leave behind what, bless you? Plus what? 1. Really important, x plus 1. Because it's just like we divided the x. Plus, notice my plus sign does not magically disappear. Kyle, what would you factor out of this bad boy?
5.
Good. When I factor out a 5, what has to remain? x plus 1. Okay, this part, I'm going to make a comment out loud. I can write it down. I'm going to do it actually here. These two things, if you've done it correctly, these must match every time. Must match. If they don't match, it means either you've made a mistake or maybe you have a problem that you can't factor with grouping. You would actually run into that problem here, so that shouldn't happen. The hardest part of this, and where it looks so strange, is we now need to write this as two factors. There's two factors here, but it doesn't really look like it. One of them is easy, I think. Can you tell me one of the two factors? X plus 1. That's the easy one. X plus 1. The second factor is hard to see, and we'll verify this tomorrow. Notice, x plus 1, it matches. We're good. I'm going to use this term and this term to get my other factor. What is my other factor? X plus 5. We will be doing a bunch of these tomorrow. We'll have an assignment tomorrow. Later.
I remember doing these, but like very different.
So I would love to see the way we write it, the format is probably very different, Angel. Like, I agree with you. I don't think that mathematically we're doing anything different. We just, each person has their own way they prefer to organize it. If you hate the way that I organize it and you like your way, I'm fine with it. I might make you explain your way to me, but you don't have to use my style. I mean, you should, because I do nothing but drip, but cool.